Hello, Math 7 students. This is Integer Addition and Subtraction Reteach. We're going to go over some of the concepts that we missed from our previous test. So, to get started, we're going to talk about if we should be using positive or negative numbers to represent each of these situations. We have number 1, above sea level. 2, below freezing temperature. 3, depositing money into an account. And 4, withdrawing money into an account. Students have already discussed these in class, so let's go over them on the recording. Above sea level elevation, what does that actually mean, and what I use a positive or a negative integer for that? Great, Alexandria. Yeah, I would use a positive. Why would I use a positive? Yeah. It's above sea level, so above sea level is going to be a positive number, and I can always represent this with a picture. Here would be like a mountainside. Here is the water level. So above sea level elevation is up. It's the positive side. If I was diving below the water, or there are some places, it sounds strange, but there are some places that have below level elevation, even though they're not underground. For example, if you are surrounded by some mountains, you could have below sea level elevation. But are you, if you're living here, are you underwater? No. So you could have below sea level elevation even with where you live too. But most of the time, if we're below sea level elevation, it's because we are underwater. Okay, what about number 2, below freezing temperatures? Is that going to be a positive or a negative number? Let's go, Haley. Negative. Why negative? Yeah, it's below 0. Below freezing. So we could draw our thermometer, and our thermometer would have, here would be our freezing temperature, which would be 0 degrees in Celsius, and anything above that is going to be positive, and anything below that is going to be negative. So if it's below freezing temperature, it's colder than freezing, that would be a negative integer. Depositing money into an account, and this is where we struggled. Depositing money into an account. Sophia. Yeah, this is a positive, but why is depositing money into an account a positive amount? Go ahead. Go ahead, Summer. Yeah. Great. Adding money to an account. And here's, I think, where some students maybe got confused, is they feel like this word right here means deduct, take away. That D, a demerit, is a negative thing, but we are depositing money into the account because we are adding money into the account. And sometimes it's not always us who's doing the adding of the money. Maybe a friend is giving you money. Maybe your job is depositing money. All of those would be extra money added to your account, so that would be positive. And that gets right to the heart of the matter, withdrawing money from an account. Is that going to be a positive or a negative, withdrawing money from an account? Great, let's go, Alexa. Yeah, this is negative. Why is it negative? What does it mean to withdraw money, and why is that going to be negative? Yeah. Exactly, taking out the amount of money, taking out money. So sure, sometimes when I take out money, now I have money in my hand that I didn't have before. So sometimes we feel like that might be positive, but we're talking about what's happening in the account. And sometimes when we take away money, let me rephrase that. Sometimes when we withdraw money, it's actually not us withdrawing the money, it's the store who withdrew money to pay for the groceries that you just took. Okay, so withdraw is money taken out of the account. So that is going to be negative. Okay, now that we have a better understanding of those, let's talk about absolute value. Our first set of problems are absolute value problems. And we continue to have some mistakes with these. I need you to understand that when we see these symbols right here, we say absolute value. And when I say absolute value, I'm thinking, and what I'm really asking is, how far away is it from 0? We typically didn't have too many mistakes on a problem like 5 or 6. So let's start with a baseline understanding. Number 5 and number 6, talk at your tables and answer those questions. What are we saying and what does that actually mean? We're going to pause the recording as students work in their tables. Ready, set, go. Okay, number 5, the absolute value of negative 5. Who would like to answer that and explain? Okay, Trison? 5, why? Why is the absolute value of 5, 5? Perfectly said, it's 5 steps from 0. I'm asking how far is it from 0, and you said it's 5 away because it's 5 steps away from 0. Exactly right. So number 6 is the absolute value of 11. What is the absolute value of 11? Alexandria? Perfect. It's 11 steps from 0. Now, this is where we started to struggle on problems like 7, 8, and 9. We start to struggle because we can see that we have absolute value, but we've got more than that. But it's not supposed to be any more challenging than these other ones. I'm still asking, what is the absolute value of 10 added to the absolute value of negative 3? Well, I can't figure out what it is when I add it until I have figured out what the absolute values are. That's no different than what we just asked. So what is the absolute value of 10? It's 10 because it's 10 steps from 0. What is the absolute value of negative 3? Kyron? 3 because it is 3 steps from 0. But I'm not done with this problem. Now that I've answered how far each of those are individually, now I'm asking, okay, what is this plus this? What's 10 plus 3? 13. Okay, let's try number 8 then. The absolute value of negative 8 minus the absolute value of 3. I said absolute value of negative 8, so you should be saying, oh, that's easy. That is 8 away from 0, 8 steps away. The absolute value of 3 is 3, because it's 3 steps away from 0. Am I done with this problem? No, what does it say we need to do with those? What is 8 minus 3? 5. As we're going over those, think back to your test and think back to how you answered some of those problems. Did you get any of them wrong? Are you learning from it? The most mistakes happen on a problem like number 9. Because I'm asking, what is the absolute value of negative 5 minus 4? How far away from 0 is negative 5 minus 4? Yeah, I don't know either. So you know what we have to do first? We have to answer, what's negative 5 minus 4? So let's focus on that for a second. What is negative 5 minus 4? Do you have the answer or are you going to explain your thinking? Explain your thinking and you can go ahead. Go ahead, Summer. Okay, that is a great thought process. I'm going to try and summarize and repeat everything that you said for the recording. You said, I recognize that this is taking away balloons, right? So taking away balloons. Taking away balloons does what to the basket, folks? Makes it go down. So how else can I make the basket go down? Add rocks. That's exactly what Summer just described. So she says, this is kind of hard for me to do in my head, so I'm going to make the change. And I'm going to call it the absolute value of negative 5 plus a negative 4, where I'm adding rocks or adding negatives. Now, this is a lot easier to do in my head. What's 5 rocks plus 4 rocks? That's 9 rocks. You can make that change if you would like to. But notice we still haven't answered this question. We now know that negative 5 plus a negative 4 is 9 rocks or negative 9. Have I answered how far away it is from 0 yet? No, we have to now answer how far away is negative 5 minus 4 from 0? What's the same distance as negative 5 plus a negative 4, which is the same distance as negative 9. And now we can finally say how far away is negative 9 from 0? It's 9 because it's 9 steps away. So yes, that one is multiple steps, but it's the same steps that we've already seen before in a lot of our other exercise and practice. And that's what we're going to see throughout the rest of the front side is just lots more practice. I think sometimes we get ahead of ourselves and we think that we've practiced this so much that maybe I don't need to draw that model anymore, but I really want us to make sure that we take the time to think about these problems, whether it's writing a sentence or drawing a model of some sort. Our biggest mistakes come from treating addition problems the same as subtraction problems. And we can't treat them the same. They are different. So on number 10, let's at least write down what's happening. This is 11. That's a positive number, so that's going to be 11 balloons. And what am I doing in this problem? Adding. What is it that I'm adding? 8 rocks, 8 negatives. We have focused recently on subtraction so much that you guys forgot what it means to even add to the problem. And all that means is I'm going to start with 11 balloons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. There's my 11 balloons. When it's an addition problem, that just means this you're going to go ahead and take and put it in the basket. You don't have to worry about, oh no, do I have enough? Because literally it says, just put it in the basket. That's what add means, put it in the basket. What is it that I'm putting in the basket? 8 rocks. 1, 2, 3, 4, 5, 6, 7, 8. What happens when I do this though? What happens when I have a balloon and a rock paired together? Alexandria. It becomes 0. So as I add these together, I'm going to be pretty strategic and I'm going to add them together in ways that I can easily find those 0 pairs. Let me give myself more flexibility here. That positive and that negative, 0 out. Positive, negative, 0. Positive, negative, 0. Positive, negative, 0. And I'm going to align each of my rocks that I just added to the basket. I'm going to put it really close to a balloon so that I recognize those are all going to be zeros. What is it that I still have in my basket now? 3 positives. Which means 11 plus a negative 8 is equal to positive 3. I'm going to skip for a second because I want us to be able to bounce back and forth between an addition and a subtraction problem. So let's skip down to number 13. Number 13, let's think about what this problem is actually saying. Negative 3 minus 10. So what do I really have? What is that going to, let's pause the recording as you guys give that one a try first, and then we'll finish going over. I'm going to pause the recording as students in class try it. You pause the recording as you're watching and you try it on your own first. How am I going to think about problem number 13? Tanner. Three rocks. Good job. You're going a little bit too fast, but all that you've said is great. So 3 rocks, take away 10 balloons. And even now, before I even start modeling and drawing out this problem, I realize if all I have in the basket are rocks and I'm supposed to take away balloons, am I going to have those balloons in the basket? So here's my rocks. Take away balloons. Stop. Do you have balloons here? No. Here's the mistake that most of you guys would make. You're like, okay, I'm just going to go ahead and add balloons then. Is that what the problem says to do? No. It says we have to take away balloons. So when I say, oh, you know what, since I don't have it, I'm just going to go ahead and add it, you have changed the problem to an addition problem, and that's not okay. You can't just change it to an addition problem. So when we realize I'm supposed to take away balloons, I don't have balloons to do that, Tanner's next advice was, so make some 0 pairs. Notice, I still have 3 rocks in the basket. This is a 0. It doesn't count for anything. It doesn't move the basket anywhere. So I could draw as many of those as I like, and the basket is still going to be at negative 3 with those 3 rocks. The problem still hasn't changed. Even though I've drawn a few extras of these now, it's still hanging out at those negative 3. Because I'm not adding anything to the basket, I'm just saying, oh, I should probably pay attention to those 0 pairs that are always there and I only need to worry about them and pay attention to them when I actually need them. I haven't even been counting. Do I have enough zero pairs now? 1, 2, 3, 4, 5, 6, 7, 8. Close. 9, 10. So these zero pairs are just kind of hanging out in the basket. Or you can call in backpack, bring in all those zero pairs. But notice, this problem is still just 3 rocks. But now I have 3 rocks with the zero pairs. Do I have enough that I could take away those 10 balloons? Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I brought in the zero pairs just so I could take away those balloons. And what is it that I have in my basket now? All of those rocks. These 3 rocks that started in the basket and all of those rocks that came from the zero pairs. So altogether I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 rocks, or 13 negatives. So -3 minus 10 is equal to -13. Will you take just a second? Will you make sure that your paper looks like mine? I know that some of you guys might feel pretty confident, but I don't want your overconfidence to get in the way of potential learning. So please make sure that you are taking notes and drawing some models here today. There are 5 more problems to practice. We're going to pause the recording for a few minutes as students work on those 5 problems, drawing models, taking the time to really make sense of them, and then we're going to move on to the back side. So pause the recording as you try the remaining problems on the front side, and then we'll move on. Okay, let's take a look at some of these ones. Number 11 is -8 plus 6. This is 8 rocks. Add 6 balloons. Remember, anytime it's an addition problem, that just means I'm just going to go and put it in the basket. That's what addition means. Here's my 1, 2, 3, 4, 5, 6, 7, 8 rocks. And now I'm going to add 6 balloons. So I'm just going to draw balloons. Each time I draw a balloon, I'm going to place it right below a rock so that I can see positive and negative, positive and negative. All of these are zero pairs. And it leaves me with 2 negatives that did not zero out. So this is equal to -2. Number 12 is 3 rocks. Add 8 more rocks. So here's my rocks, 1, 2, 3. Whenever I'm adding, that just means put it in the basket. So what else am I going to put in the basket? 8 rocks, 1, 2, 3, 4, 5, 6, 7, and 8. I saw this mistake a lot. Are those zero pairs? No, just because you stacked them one on top of the other doesn't make them zero. So we should not draw them as zeros. Instead, count what we actually have. 3 rocks and 8 more rocks is equal to 11 rocks, or -11. Number 14, 5. That's a +5, so that's 5 balloons. And I need to take away, it says -9, so that's going to be 9 rocks. And already I can see, since this is a takeaway problem, I cannot just go ahead and put this in the basket. That would be an addition problem. This is whatever I need to take away should already be in the basket. But I'm looking at this and I'm not seeing any rocks at all. But the good news is, inside of that basket, we can always include zero pairs. We can call in backpack, we can bring in zero pairs, and as I continue slowly drawing these zero pairs, I'm going to know I have enough when I finally can see 9 rocks. So that gives me a clue. I should probably draw 9 zero pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I have enough rocks. So when I take away these rocks, I'm left with the balloons that I started with and all of the balloons that came from the zero pairs, which is equal to 14 balloons. Here's another way that we can think about this problem. You don't always have to draw models if you don't need to. When I take away rocks, the basket goes up. How else can I make the basket go up? I can make the basket go up by adding balloons. So I could have changed this problem and thought about it as 5, add a +9, and now that's one that I can do without needing a model at all. So again, the directions were draw a model or write a sentence to explain your thinking. So if you didn't draw a model, it's okay if you wrote a sentence to explain your thinking like I did there in black. Okay, the last two. Number 15 is 10 rocks. Take away 15 rocks. And in the beginning, this feels okay. Okay, there's rocks in the basket. I've got to take away rocks from the basket, so it sounds pretty good. So let's draw those rocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm supposed to take away 15 of them. And I'm looking, I only have 10. So what am I going to do here? Yeah, backpack, 0 pairs. How many rocks are there now? There's these 10, and here's 11. There's the 12th one. There's the 13th one. Here's the 14th one, and here's the 15th one. Do I have to draw 15 0 pairs? No, I only had to draw enough so that I had 15 rocks. Do I now have those 15? There's these 10, and 11, 12, 13, 14, and 15. So 10 rocks, take away 15 rocks is equal to 5 balloons, or a positive 5. Yes, Summer? What I can do is taking away rocks. What happens when I take away rocks? What direction does the basket go? Decide. Take away rocks. What direction does the basket go? Up. The rocks weigh it down, and if I'm taking away the thing that makes it weigh down, then it's going to go up. How else can I make the basket go up? Add balloons. So maybe I could think about this problem instead of having to draw a model. Maybe I can think about it this way. Negative 10 plus a positive 15. Maybe that's a little bit easier to do in your head. Number 16 is 12 minus 21. This is 12 balloons, and I am taking away 21 balloons. So again, it's kind of like the last problem. It feels like it's going to be okay. Balloons taking away balloons until I start drawing it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'm supposed to take away 21. Look at what we have here. Do I have enough? No. There's already 12. This would be my 13th, but I cannot just draw the balloon. I have to draw a 0 pair, but that's 13 balloons that I could potentially take away. There's 14. This will be the 15th, the 16th, the 17th, the 18th balloon, almost done, the 19th balloon, the 20th balloon, and finally the 21st balloon. You don't have to draw 21 balloons or 21 0 pairs. We already had some balloons here. Let's count as I now subtract them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's all 12 that were originally in the basket. Now I need to start taking balloons away from the 0 pairs. 13, 14, 15, 16, 17, 18, 19, 20, and 21. What do I still have in the basket? 9 of these rocks. 9 negatives, or negative 9. All right, let's move on to the backside where we've got some stories. And we have our chip and tile models. It says for each of these problems, we need to write a numerical expression. This was an area that you guys struggled with. A numerical expression is what we see all over here on the front side. It says find the value of each expression, and we have these number sentences where we're adding or subtracting these things. And that was the part that you guys struggled with, is just writing down those number sentences. Then we also need to write a sentence that states our answer. So let's take a look at the first one and what this looks like. A mine worker is in a tunnel 15 feet below the ground. He descends another 3 feet. What is his final position? So where is this miner starting? 15 feet Below. What number do I need to use to represent 15 feet below? Jackson, a negative 15. What does it mean if he is descending? Kyron, he is going down. Descend means he's going down. So if he's already at negative 15 and he's going down 3 feet, what is his final position? That's an easy one to answer. It's harder to write the expression. So where is he? If he's at negative 15 and he goes down 3 more, where is he going to be? And if you're struggling, draw a picture. Here's the mine worker. This is going to be 0. He's already down here at negative 15. And as he's working, he is going to go down another 3. He's going to not just fall, he's going to like climb down a hill, right? So where is he going to be? Sophia. Yeah, he's going to be at negative 18. How would I say that in these sort of terms? You're right that he's at negative 18, but what would I say, Summer? Yes, you said that correctly, but that's not quite the question I was looking for. If he's at negative 18, what would I say in like a story context? Sophia? Perfect. He is at 18 feet below ground, or his final position is 18 feet below ground. Typically, when we're talking as a story, we don't say negative 18. We instead would say 18 feet below, which means the same mathematically as negative 18. So we have written a complete sentence, but what is that mathematical expression, the number expression? We start at negative 15, and we are going down 3. Negative 15 minus 3 is equal to negative 18. Another option, I believe, Summer, you said negative 15 plus a negative 3? Yeah, those both work. Either one of them would have worked. Going down, we're subtracting 3 more feet, or we're adding another 3 negative feet. Either one is great. Number 18, a lot of mistakes on a problem like this on the test. Draw a picture. There's a drink shop on 200 North. So here's 200 North. Here's the drink shop. And both Mary and Lena, they live on 200 North. Mary lives 4 blocks west of the drink shop, and Lena lives 2 blocks east of it. So I had to rotate it. I drew that wrong. Mary lives 4 blocks west. Where's that going to be? I saw a lot of you guys drawing this on your paper. Had a little compass. If this is north, this is going to be east, and this is going to be west. So west is going to be positive or negative direction. Probably in the negative. So if it's 4 blocks west, I can't just say 4, I'm going to say negative 4. And Lena lives 2 blocks east of it. This is going to be east. So it's going to be not just 2, but a positive 2 if we're on the positive side. East and west are opposite directions, so I should be using positive and negative numbers to show that. How far away are they? If this is Mary, Mary would have to walk 1, 2, 3, 4 blocks to get to the drink shop, and then she'd have to walk 2 more blocks to get to Lena's house. So how far apart do they live? 6 blocks. Write that down. That's our sentence. They live 6 blocks apart. But now, what is the numerical expression that I need to use? I have to use a negative 4 because that represents west. I have to use a positive 2, but somehow I need that to still equal 6. And negative 4 plus 2, that's not equal to 6. So what do I need to do to make this equal 6? Summer? We need to subtract. When I'm asking how far apart do they live, I'm asking what is the difference? How far away are they? What's the difference? And that means we are going to subtract. Now, -4 minus 2 is actually equal to -6, but does that still answer the question that they're 6 blocks apart? No. You could also have reversed it and said 2 minus a -4. 2 minus a -4 is equal to a +6, and that also would have worked. Yes, but because I switched them, notice that this is a -6, this is a +6. So when I changed subtraction, it did change the answer, and I reflected that in those. On number 19, we have to be careful about the words. It says, Mr. O'Connor lives in North Dakota. When he leaves for work one wintry morning, the temperature is -4 degrees. By the time he comes home, the temperature has increased 10 degrees. What is the temperature when he comes home? The problem that students had with this similar problem on the test is the temperature has increased 10 degrees. Keep in mind what those words mean. It doesn't say it has increased to 10 degrees. It means it started at -4 degrees and it has increased 10 degrees from there. So I'm going to draw our thermometer. Here's going to be 0 because we're below freezing. Here is that -4. I want us to think about what it means when it has increased 10 degrees. That means it starts here and it has increased 10. Let's think about how much that has gone up and where we're actually at. The first, let's see, from here to here, that's going to take away 4 of those degrees that it increased, and that gets me to zeros. So when it increases those first 4 degrees, it'll be at 0, but we're not done increasing. It has increased a total of 10. Here's 4 of it. 4 plus 6 is going to get us equal to the full 10 degree increase. Does that make sense? We've got 4 plus 6 right here. That's a total increase of 10 degrees, but I did it in stages. The first 4 just got us to 0. The remaining 6 get us all the way up here to 6. So the model helps us to see the temperature didn't go all the way up to 10 degrees, but it increased 10 degrees starting all the way down here at -4. That also gives me a clue as to what the number sentence or the numerical expression is going to be. -4 plus 10 is equal to 6 degrees. It is 6 degrees when he comes home. Nice chilly 6 degrees. All right, for the last 2 problems, here is what we need to do. We are going to draw a chip tile model, that would be some sort of rock and balloon model, and a number line model, and then find the result of the expression. Again, look at some similarities and differences. Students struggled treating these problems the same, but number 20 is an addition problem. Number 21 is a subtraction problem. I should not be getting the same thing on each of those problems. So as I'm preparing to draw a chip tile model, I'm going to pause and think. This is 8 balloons, add 10 rocks. I'm going to draw my 8 balloons. And since it is an addition problem, I'm simply going to add 10 rocks. So I'm going to start drawing in 10 rocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And as I do this, I'm going to see balloons plus rocks, we're going to have some 0 pairs. I can stack those and I can see all of these are going to be 0 pairs, and what I have left is 2 rocks. So 8 plus a -2 is equal to, 8 plus a -10 is equal to a -2. The number line model, again, we've been over subtraction so recently that you forgot how to do a number line model for addition. When we're drawing our number line model for addition, we're just showing the movements of the basket. So So our magical floating basket always starts at 0. But this magical floating basket is at 8 because of those 8 balloons that we're pulling it all the way up here to 8. But then I added 10 rocks, and every time I add a rock, the basket sinks lower and lower and lower. So 1, 2, 3, 4, 5, 6, 7, 8, back to 0, 9, and 10. Those 10 rocks made it sink so low, it is now below 0 at -2. Number 21, same numbers, but this is a subtraction problem. So this is 8 balloons, take away 10 rocks. When I draw my 8 balloons, I realize I'm supposed to take away rocks, and I don't have any rocks at all. So as I'm making this model now, I need to realize I need to draw some 0 pairs. So we can call in backpack and we can draw in those 0 pairs. But again, notice I'm not just drawing rocks. If I were just drawing rocks, that would be an addition problem. But it says I need to take away rocks. I don't have any, so I draw 0 pairs. There's always going to be rocks in those 0 pairs, and so that's what I'm bringing into the basket. Zeros, and in those zeros, I can see the rocks. Here's 1, 2, 3, 4. I need 10 of them, so I need to keep drawing. 5, 6, 7, 8, 9, and 10. Here's all of the 0 pairs that I need, and now in those 0 pairs I can see all of the rocks that I need to take away. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 rocks have now been taken away, but that leaves me with those same 8 balloons that already were in the basket, and now I have all of these balloons that came from the 0 pairs when I took the rocks away. So 8 minus a -10 is equal to a positive 18. Here's how I would model that on the number line. Remember, subtraction is a difference, so I need to show the directional difference on the number line. I'm really asking how far apart are these numbers, not how far apart from 0. I'm not asking absolute value. I want to know how far apart are these numbers from each other. So I'm going to find the number 8 on the number line. I'm going to find the number the number -10 on the number line. And I want to know how far apart are those numbers. I can take individual baby steps, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That gets me to 0, but I still haven't made it this far. 10, 11, 12, 13, 14, 15, 16, 17, and 18. They're 18 steps apart from each other. The difference is 18. But I do need to pay attention to the directional difference. That directional difference means the side that I start on matters. Here's the number 8. Our problem starts with 8. Here's 8 on the number line. So this is the start of the problem, and it is on the right-hand side. So when I start on the right, that makes it a positive number. So it's not just 18, it is a positive 18 steps. That is it for our reteach. Thanks for watching. We'll see you next time.